What if ships could sail over mountains? Most nations would say it's impossible. China didn't ask what if, they built it. The Goupitan Ship Lift, a $7.7 billion mega elevator, hauls 10,000-ton ships, each as tall as a 66-story skyscraper, almost 200 meters into the sky. A floating titan, bending gravity to its will. But behind this engineering marvel lies a story of necessity, strategy, and ambition. A story that goes far beyond moving cargo from point A to point B. China's rivers have carried life, culture, and trade for thousands of years. But in Guizhou province, the Wujiang River has always been more obstacle than ally. Here, jagged limestone mountains rise like dragon's teeth. Valleys plunge hundreds of meters deep. Monsoon rains turn gentle streams into roaring torrents. Landslides wipe out roads without warning. For centuries, this region was called the mountain that devours men. Moving cargo meant either struggling up crumbling mountain roads or attempting dangerous river passages. Both were slow, expensive, and deadly. Even with modern engineering, traditional canal locks couldn't solve the problem. The nearly 200-meter elevation change would require over 20 lock chambers in a row, taking days to pass and costing millions to maintain. The result? Shipping from Guizhou to Shanghai could take 2 weeks, costing triple the national average. Industries struggled, foreign investment stayed away, and a province of 36 million people was cut off from the nation's economic heart. Faced with an impossible geography, Chinese engineers flipped the problem on its head. Instead of forcing the river to adapt to trade, they would make trade adapt to the river. The solution was bold: a vertical water highway, a ship lift so massive it could carry vessels the size of football fields directly over the mountains. Where other nations might have settled for partial fixes, China committed to building one of the largest mechanical structures on Earth. And so, the Goupitan Ship Lift was born. Imagine guiding a cargo ship into a steel chamber longer than a city block. Behind it, 400-ton hydraulic gates slam shut with surgical precision. Pumps roar to life, filling the chamber with water until the ship floats as if still on the river. The chamber, now over 11,000 tons with vessel and water, begins to rise. Slowly, the valley drops away. Villages become specks. The river becomes a ribbon of silver. Mountains that once blocked all passage slide past your window. In just 30 minutes, the ship climbs higher than the Statue of Liberty and the Great Pyramid of Giza combined. Then the forward gates open, revealing a vast upper reservoir. The ship sails out, continuing its journey as if nothing extraordinary just happened. The Goupitan Ship Lift is a floating fortress. Chamber size 40 meters long by 12 meters wide. Empty weight 3,000 tons. Full load weight over 11,000 tons. 4 reinforced concrete towers, each anchored 70 meters into bedrock, guide the chamber's vertical journey. A network of 256 high-tensile steel cables, each made from 127 individual strands, pulls the chamber upward. These cables alone could stretch over 80 kilometers if laid end to end. The lift uses a gear rack climbing system with interlocking teeth that must engage with millimeter precision under enormous pressure. Each tooth is forged from a special alloy, tough enough to handle repeated stress, yet flexible enough to absorb micro-vibrations from wind, water, and even earthquakes. Sensors constantly monitor weight distribution, water levels, and cable tension. Hydraulic dampers, holding enough fluid to fill an Olympic swimming pool, stabilize movement, absorbing forces equal to a small meteor strike. The entire system consumes enough electricity to power a small city, much of it generated by the dam itself. Backup generators ensure the chamber can always return to a safe position, even during a blackout. Every lift cycle is a high-stakes ballet of engineering. 5 independent computer systems monitor every motion, each checking the other's calculations. If even one system detects an anomaly, operations pause instantly. In under 2.5 hours, an entire mountain range is bypassed. At full capacity, the lift can complete 24 cycles per day, moving up to 5 million tons of cargo annually. The impact on Guizhou has been dramatic. Shipping costs dropped by 67%, industrial output rose by 42%, foreign investment soared by 83%. Factories that were once too remote now have direct access to China's busiest inland trade network. New jobs have emerged in logistics, maintenance, tourism, and manufacturing. Even rural villages benefit, with better market access for agricultural products and growing tourism around the lift itself. The Goupitan Ship Lift isn't just about regional prosperity, it's part of China's dual circulation strategy, designed to keep goods flowing internally even if global trade routes fail. Alongside projects like the Three Gorges Dam and the South-North Water Transfer Project, it forms part of an inland network that could sustain China's economy during global shocks. It's also a tool for climate resilience, regulating river flow, preventing floods, and ensuring navigation despite changing weather patterns. The lessons learned here are already shaping the next generation of ship lifts, taller, faster, and more efficient. China's engineers are exporting this expertise to Southeast Asia, Central Asia, and Africa as part of the Belt and Road Initiative, turning their mastery of extreme engineering into a global product. The Goupitan Ship Lift is more than a machine. It's a statement that mountains can be bent, rivers can rise, and trade can flow where nature once said it could not. It doesn't just move ships. It moves economies, and perhaps the future.